Hi folks, how you doing? Um, well, you're obviously here because an element of your course is got something to do with statistics. So, um, well, we might as well go for it here. So this is just a little scenario here, and you know what the topic is because you saw that when you clicked on the video link. So here we go. So we get some kind of fluid in a bottle here, strawberry something, jelly belly, whatever that is. So it doesn't matter what the fluid is. The thing is, it's in a bottle here, so this is important for our story. Um, right, so in the little story there that you can see, and you probably heard of it in class, it's saying here uh, that in this factory, sometimes they have to sample the contents of the bottles just to make sure that we get almost the exact amount in each. But we don't have the time to test every single bottle, um, and it's not cost effective. So what they usually do is they'll either decide on a time or they'll take them at random, and they won't probably don't test every machine. They might have over 100. So just for the sake of this example, I'm only using two, and I'm only taking a sample of 10 bottles of each and measuring the contents of the bottles. So what I'm doing here is that I'm calling them machine A, machine B, and it's saying that the contents are in milliliters. So from each of the machine, we've measured the sample, the volume. Okay, so on the left hand side, we've got the values there. What's to the nearest milliliters I'm going here, and machine B likewise. Okay, so there's a couple of things that we're going to do here. But before we do that, because I didn't have a picture that showed the back of the bottle, I'm just going to have to show it here. It's saying that the contents are 500 milliliters. Maybe I should have changed that to average contents. Sometimes they put that, sometimes they don't. Right, okay. Two tasks we've got here. Can you calculate the mean or the mean contents? So that's the arithmetic average that you're familiar with, or you should be, from both machine A and machine B. Right. So I brought back here the values from machine A and machine B. So you should know, in order to calculate the mean, you would add up. So from machine A all the way from 502 at the top all the way to 503, add them all up, get a total, and divide by how many bottles, which was 10. So add them all up, divide by 10. Do likewise with machine B. Add up all the volumes that you've measured out, or someone measured out, and divide by how many? 10. So have we done that there? Remember, you can always pause this. It is good to interact, and we'll see how we go on. So we've measured them, the average or the mean, and what did we get? Well, I hope you did get 500 mils. Okay. I hope. If you didn't, can you just go back and check? So a lot of the time, we maybe press the wrong button on the calculator, or we'll try to do it on our head. Right. But at least I hope you're participating. Right. So the mean was 500. Did you expect that? Hmm. I would have expected that because on the label, that's what they're saying the contents were. Right. There's a setting task, and here, what they're saying, if you just go and look at the numbers from machine A and machine B, it's saying which one do you think is operating? They're saying more efficiently or better. Okay, so just go and have a look at the numbers there and see how you got on there. So machine A, machine B, just information you've now got is you know that the mean arithmetic average is 500 mils. So what you're kind of looking at here, maybe from machine A, what's the the biggest number, and from machine A, what's the smallest number? So for machine A, what have we got there? 505, that looks like the biggest value, and 495, that's the lowest value. So for this machine, that's a difference of 10, that would be called the range. So 5 above and 5 below the mean. Okay, right, let's have a look at, let's do something similar with machine B. So what's the biggest number? 520, 5, oh, that's right down there. 529. So that's my biggest number. That's quite a bit above. And let's go for my smallest number, 485. No, oh, no, I get 471. Right, just a quick calculation, and you can do it as well. 529, well, that's 29 above, and 471, that's 29 below. So just using a kind of, basically we looked at the range there, biggest and smallest from each. So when we did that, hopefully you thought that machine A was working better. And what I'm putting here is they're closer to the mean, and that's what we want here, things to be closer to the mean. And the mean or the arithmetic average, that's a very important, what we call characteristic of the data. It's very, very important. Okay, right. So, but like I said, even just the mean and the range, that doesn't tell us about everything involved here. So, well, let's think. Before we do that, let's bring on board, not that, another set of data. So if I had, instead of A and B, I went all the way down to Z or Z. Just looking at these numbers here, if I was to look at the extreme values, 440 and 560, well, that looks like I'm 40 below and 40, or sorry, 60 below and 60 above. So that's quite extreme there. That's a lot greater than plus or minus 29 that we had for machine B. And what you might also notice, see the rest of the numbers? They are bang on the mean. So just looking at the mean and the range, it doesn't tell us um, everything. Okay, so we need something else here that lets us know how close things are to the mean, or near or far. The nearer the better, and that's called the standard deviation. Deviation means to deviate from a certain reference point, and our reference point is the mean here. In statistics, they like to use a lot of Greek letters, so here sometimes they use this letter here, and we call that the letter sigma. And we'll also use the capital letter sigma. You might have seen that before. So, but for us here, SD for standard deviation, we should be okay with that. Right, so we might as well just jump into it, and we're going to calculate this thing called the standard deviation of a set of numbers. So this set of numbers, it ranges from 6 to 13. I've got them going from the smallest to the biggest, left to right. And just looking at those numbers, if I have to think, oh, what's the sort of average there? Well, average middling values, as it suggests, in the middle somewhere, in that kind of region there, 8 to 11. See, there's lots of 9s there, so maybe 9-ish. Right, maybe we come to that. Anyway, to calculate this thing called the standard deviation, we've got some formula that somebody's made up. They've told me and I'm telling you. Right. and it's not quite pretty, but we'll go and explain all the little things that are in that formula. Okay, so that thing there, that's big sigma. Okay, so big sigma, that's what that symbol there means. So big sigma means add up, or to sum your numbers. So our numbers we refer to as x. We like to call our numbers x. All the x's make up our data. So we've got lots of x's, okay? X is just our reference to the numbers. Right, so that's what that is. That's in the formula. Next thing, the sum of your data squared. So that kind of W on its side, that's the same. But what's this x squared? X squared. Well, if you have to square a number, you multiply it itself, but use your calculator. So if it was 5, and you have to square it, 5 squared is 25. If it was 6 squared, it's 36. 7 squared, 49. So if you had 5, 6, and 7 on your original list, and it asks you to square those and add them, because that's what the sigma means, you'd 5 squared plus 6 squared plus 7 squared, so that'd be 25 plus 36 plus 49. Right. Okay. Again, hopefully that's straightforward. That's the number of things that you've got in your sample, in your list. That's what we've got there. Okay. Let's, as I says, moving swiftly on, we're going to go for it. Right, so we've got that list of numbers there, and the way we're going to go through it here, sometimes it's easier to write things kind of going down the page here, so I'm going to write them out as a column. So instead of horizontally, we're going to go vertically. So that's what I've done there. So just double check that all the numbers are the same, you haven't missed any out. Okay, so we'll go that there. So that's my X column. So that's my original numbers from the list. They are in the X family. We're fine with that. Okay. Right. So what I'm going to do with those numbers there is add them up. Okay? That's what I'm doing there. That's the sum of all my X numbers. That's what that is. The sum of all my X numbers. Right. Let's move on. So I've introduced this thing called x with a v2, x squared. So we're taking each of our numbers individually, take them individually, take 6, square it, take 7, square it, etc. All the way down to 13, square it. Use your calculator. Speak about calculators. Get away. Speak about calculators later. Right, okay. So 6 squared, 36, 7 squared, 49. Just remember, squaring is not times in the 2. 8 squared, 64. There's a few of them. A few 9 squares. And all the way down to 13 squared. Once you've squared all your numbers, can you add them up? Okay. And always double check your calculations here. So what have we got here? The first column, we added them up. So that's that wee kind of W on its side. That's sigma x, the sum of our x numbers. We got 92. That's what that was there at the end of that column. The other one, we created an x squared column. We squared all our numbers, added them up. So that's what that is. That 890. That's the sum of x squared. Okay. They are the two of the things we need. The sigma x and sigma x squared, they are in our formula. So just to get you right, that's in the formula, and that's in the formula. Okay. Right. What else is in formula? N. And for us, it was 10 things that we had. That was going all the way from 6 to 13. So we had 10 things. So that's what N is here. Right. Let's go and get this formula. There it's there. So we're going to put in our numbers here. So if you just, you might remember, that was sigma x squared, that was the second total, and what was that? Was that 890 in our example? I think it was. And do we think inside the bracket, it's in the bracket, forget about everything else, the sum of x, I think that was 92. So we'll put them in as well. And the only thing, one other thing that's going on here is you've got an n there, and you've got an n there. So, and for us, that was 10. So, I've got rid of those symbols there. We know what they are. Get your numbers in. And what I'm going to do here, once my numbers are in, I'm going to identify certain parts. I'm going to do it a wee bit of time so that it doesn't matter about the bracket, especially if I do it just one wee bit at a time. So 92 squares, use your calculator. Don't do 92 times 92 because we're in the big grown-up class now. 92 squared, see what you get. 8464, who knows? It is. Next thing I'm going to do here, I've left the 10 over 1 on the bottom here, and so I think I'm going to sort out 8464. I'll get an answer for that, and then I'll do 10 take away 1 to get 9. So I'll do them at the same time here and see what I get. Right. There's no point hurrying things up, so that's what I've got there. Right, I'm okay with that now. So things are starting to reduce a wee bit. So I think I'm going to finally tidy up that top line there. So 890 take away 846.4, and hopefully I get 43.6 over 9. You could put it into your calculator at this point. If you were putting it in, you hit the square root first, okay, and it'll automatically open up a bracket. Right. You really need a scientific calculator, because when you're putting this into your calculator, you would hit the square root, it would open up a bracket, you would then type in 43.6, the fraction means divide, okay, because that looks like a fraction, doesn't it? And once you put the divide by 9, close the bracket, then hit your equals in your calculator. Right, do it in that order there, folks. Your lecturer's job is not to show you how to work a calculator. That's your job. Google it. If you decide to use a phone app, maybe we're in the COVID zone, I don't know, maybe we're out of it. If you're using a smart app, it's up to you to make sure you know how to work it, not your lecturer, okay? Do you know what the best idea is? Get a real scientific calculator, okay? Keep the book and read it, because that's your job. If you're doing a course with a statistical element in it, you need a real calculator, okay? That's my kind of rant here. See, if I was a GP, a general practitioner, doctor, I would probably have a real stethoscope. I don't think I'd have two flexi straws coming out my ear, joined onto like a paper coffee cup, and use that. Okay? Because it might, I don't think the patients would be quite pleased. I'm the patient here, okay? Right, rant over. Oh, don't take things personally. Take them on board, okay? Because that's what I do, and it's good. Right, so see, once you've done all that there, once we've done all that there, hit equals, and what do we get? No, 2.2. Right, see, for us here, we don't really need to know about significance of standard deviation. But if you're in my class, and if you are in my class, you will have access to this document here that I'm showing you. So this document here, apart from all your basic statistics, your mean, your mode, your median, takes you all down there. You should have all seen that. If you haven't, I would like to know why not. You're not doing yourself any favours. So underneath all the basic stats, we spoke about range to do this initially. Once we've done all that there, we then kick in the standard deviation. So I'm talking you through it. Okay, and so I just want to show you we're doing exactly the same thing. Giving you a little introduction here. Yeah, there you go. So I'm explaining exactly the same in the notes, except you don't have to listen to me. Yeah. So everything's exactly the same. But then going and looking for some examples. I happen to like mushrooms, that's fine. So and it's just spread it over 2 pages there. It's just to show you that everything's exactly the same. Once you've done your calculations, you then go left hand side, go and put everything in your calculator, and that's you. So what I have done, so you need to move you out of the way. There is a section. It's just in case later on, if you do go on to do some more statistics that involves standard deviation, I put in a little explanation about the relevance of standard deviation. So I'll let you do that in your own time, and I've sometimes referred to it as confidence limits. We can be confident that lots of our numbers lie between certain values. So you just take your time and go through that, folks. Right. Okay. So that's there. So let's go back to that there. So at any point, you can just rewind that. So what I'm going to do is I'm just going to give you an example. Okay. So there's your little example here. So can you go and work out, the mean and standard deviation of these numbers? We never worked out the mean for the other ones, but if you remember that the total of the first column was 92, all you would do would be divide it by the number in the sample. So 92 divided by 10 is 9.2. And if you remember back, if you rewind, we said, and I said, it would be kind of roughly 9-ish. So 9.2 seems fine. So you can pause the video here and go and calculate the mean standard deviation. I think I'm just going to kick in the standard deviation here. There's only 6 numbers, so write them in a column, 12 down to 20. Okay? That'll be your x column. Probably add them up. Okay? Then create another column, x squared, so you'd be 12 squaring 12, squaring 14, all the way to squaring 20 at the end. And we'll go and get our totals and see how they go on. So here we go. There's my first column. That's the list of numbers. That's my x numbers. So I'm just going to go square all these. Sorry, not square them. I'm going to add them up. Okay, so 12 all the way down to 20. Add them up. So we get 96 here. Right. That's the number. That's one of the numbers that we need. That's the sum of our x numbers there. So that's why I've written that. Right. Okay. So I need another column here. So I'm going to take all my x numbers. Okay, those 6 numbers, and I'm going to create another column. So I'm going to square 12, square 14, all the way down to 20 and square that. Right, so that's 12 squared. That's 14 squared. Just keep going down. Okay. And once we've got all our numbers with your new calculator, your real hands-on calculator, scientific calculator, add them up and double check it. There you go. So those two numbers here were two totals from both our columns. We are going to use them. Right, so that's a sum of our squares in that column, and the first column, that was the sum of all our x numbers, the original numbers. Right, we need those, but we also need to know the value of n. And the value of n was how many did we actually have in the original sample. Right, so how many did we have in our sample? 1, 2, 3, 4, 5, 6. Right, that's what we had. So, and that's what happens when you're so. I've just introduced a new page. That's fine. Don't worry. So that's our n value is 6. Right. That's the 3 values I need for the formula. So there's our formula. Let's go and get our numbers here. I'll just go back just to remind us. So 1578, that's going to be the first number at the front. 96 is going to go in the little bracket, and n equals 6. It appears twice. Okay. So get rid of the fancy symbols. So 1578 goes in there. What was in the little bracket that's going to get squared? Was that 96? I think it was, yeah. And underneath the 96 squared, we're going to have 6. And downstairs in the big fraction, we're also going to have 6 take away 1. Right. What I think I'm going to do here, just like I did in the last one, the first bit I'm going to tackle is the squaring of the number. So 96 squared, do that on its own, and I'll probably do the 6 take away 1 at the same time to get 5. And just in case you're wondering where these things are appearing from. Okay, so I've got that there. I think the next thing I'm probably going to do, because I've got a fraction within a fraction, I'm going to take care of the 9216 divided by 6. I'll sort that out to get one number that will be 15 something something. Right, I've taken on a new page. That's fine. I'm allowed to. It's my game. So I'm going to divide that now. 9216 divided by 6. I get 1536. That's fine. So the next thing I'm going to do, 1578 take away 1536. Sort that out. Okay. 78 take away 36. What's that? 42. Something like that. So I'm going to 42 over 5. Done that. You can put that into your calculator, just like I showed you with the last one. So if you're using your calculator, hit the square root button. It'll open up a bracket. Hit 42. Okay. Hit divide, because that's what the fraction thing's telling you. Divide by what? Divide by 5. Close the bracket. Hit your equals button, and it's going to give you your answer. So that part there, that's down to you. You know how to use all your smart filters on your phone, on Instagram, etc. So pay the same attention to your calculator, and not your smart app calculator, a good honest calculator. Right, okay. But I know, seeing this one, I know that 42 divided by 5 gives me exactly 8.4. So that's why I've written it like that there. You don't have to do that. You can put in square root 42 divided by 5 equals, we will get the same answer at the end. So square root of 8.4, if I was to do that, 2.9, I'll get the same answer regardless here, folks. Right, With the level of course that you're doing here, as long as you can take it down to that there, as long as you can go through the mechanics, okay, that's all it is. Just bring you back to the main document here. You're given your list of numbers, okay, initially, okay, extreme left hand side, that's your X column. Get your list of numbers, take them down, get your total 141 in this case. Column next to it is the square of all your numbers. Done that. Add them up. Okay. You can see on the right hand side, just next to the mushrooms, n is 10 in this one here. We'll get the sum of x. I've highlighted them. The sum of x squared, I've highlighted them. Get your formula, put things in position, and gradually take your time. Okay. Take your time, take your time. All the way down to there. And this one here, I've actually put it in the units of measure. So in my standard deviation question about the bottles, I actually never worked at my, did I work at my standard deviation? No, I didn't, because those numbers were too big. But if I did, I would have put down millilitres, whatever it was there. Right, folks, I think I'm going to leave it there. So just remember, this was just like your classroom lesson. In fact, it was your classroom lesson. So you just go through all the stuff there, and yet again, I will say, get a real calculator. Okay, and then that means you'll be able to work out your standard deviation for your tangy toms. Okay, right, folks, I'm going to finish it there. And if you're watching this, it means I've uploaded it. Okay, so bye for now.